So from the MyStatLab homework, it appears problem 35 has been giving a lot of people trouble. It's the central limit theorem problem. And I sent emails to several people last night, said I would upload a video that walks us through this problem. So what it's asking us to do is compare the probability of selecting one person with a height of less than 65.2 inches, or what if we were to select repeated samples of 16 women and how they would compare at less than 65.2 inches. So the height of women ages 20 to 29 is normally distributed with a mean of 63.8 inches. Assume sigma equals 2.3 inches. Are you more likely to randomly select one woman with a height less than 65.2 inches? Or are you more likely to select a sample of 16 women with a mean height of less than 65.2 inches? And explain. So that's parts A, B, and C. Well, part A, we do the same way we've been doing it. Yeah, I kind of have everything color-coded. There in yellow, you see I have the mean. I don't know what color this is. I think, do they call it teal? I don't know. To me, teal is a duck. But anyway, 2.3 inches is the standard deviation, and then we have a probability statement of x less than 65.2. And you see when I plug my mean in of 63.8, standard deviation of 2.3, probability of x less than or equal to 65.2, and there's my answer, my probability of 0.7286. So we have over 70% of getting one person. And that makes sense because we're above the mean and we're crossing over the mean. So we would expect this to be well above 50%. So that's especially with a 2.3 standard deviation, 63.8. So here's where the part that's giving everybody trouble is that what do we do now? And this is where we use the central limit theorem. What is the probability of randomly selecting a sample of 16 women with a height less than 65.2 inches? Well, again, we have the mean is still the same. That doesn't change. The standard deviation is 2.3, but it's going to have to be adjusted. We're going to talk about that, and that's what makes the difference for a central limit. And we use the sample size of n equals 16 to make that adjustment. And the probability of x less than or equal to 65.2, that is the same. And you're going to see we're going to end up with a 0.9925. Let's see if I can fix that. Maybe. There we go. There's, I wanted to put that in bold. Also, you notice I have this highlighted down here for the standard deviation, and there's a reason for that. So we're going to make the adjustment, and we know from the central limit theorem that standard deviation is adjusted by you take the standard deviation of 2.3 and you divide it by the square root of n, the square root of the sample size, which is 16. Now, you don't have to do this calculation because StatCrunch, we can type it in as 2.3 divided by, there's the / SQRT, and 16 in parentheses. And that's what's going to go in here in the standard deviation. I'm going to pull up and show you what that looks like. So let's see, my standard deviation was 63. This was 63.8. My standard deviation, now we're not going to be able to see everything in the field, but it's 2.3 / SQRT, open parentheses, 16. Told you I don't type any better on these videos, do I? 16. And we still want less than 65.2 inches. So this was the trick up here, is how we enter that standard deviation that changes, and sure enough, we get a 0.9925. Let's go ahead and leave this. And did I put everything in right? 63.8 2.3. Well, let me have one more look at StatCrunch and make sure. Yeah, we're good. Okay, so now we see this probability is significantly larger than this probability. And here's why we should expect that. When we did our experiment previously in the semester where we did the coin tosses, remember how the coin tosses, the bigger the sample size, the closer we came to the theoretical probability. So the fact that we're going across the mean and we're adjusting the standard deviation, we would expect a larger probability, and sure enough, we have one, 0.9925. The fact is, as we increase the sample size to 16, we can expect that everything gets closer to the mean. So, are you more likely to randomly select one woman with a height of less than 65.2 inches, or are you more likely to select a sample of 16 women with a mean height of less than 65.2 inches? It's more likely to select a sample of 16 women with a mean height of less than 65.2 inches because the sample of 16 has a higher probability. Now that's because the probability statement, notice when we shaded both of these, we go across the mean. We would have expected in this case for this probability to be higher. Now, if we were not going across the mean with our original probability statement, we would actually see the opposite thing happen. So be prepared for that. All right, everybody, I hope this helps finish up those homeworks. And please, please, please review the video.